Hello everyone. On this video we will be looking at circles and how to find the area of the circle. Okay, so first let's identify the parts of a circle. Okay, so first you have your diameter. Okay, so if you have the center of the circle, going through the center of the circle, the diameter reaches from one side of the circle to the other. Okay, and then you have your radius. Your radius is simply just from that same center to any part on the circle. So you can go from the center to this point, the center to this point, the center to this point, the center to this. It doesn't matter where you go. If you go from the center to any point on this circle, the radius will be the same. Same here. If you have your diameter, if you go from this point to this point, as long as you go through the center, that diameter will be the same length all the way around. Okay, so these are the written definitions. Distance across the circle through the center for the diameter. The distance from the center to any point on the circle is your radius. And the circumference is the distance around the circle. So if you start at any point and you go around that circle and go back to that point, that's your circumference. No matter how big or how small the circle is, if you start at a point and you circle that entire circle and go back to that point, that's your circumference. Okay, so now we're going to use these three things to come up with our formulas. Okay, so I'm just going to go up here. And these are your formulas for a circle. Now, if you have your circumference divided by your diameter, that's going to always equal 3.14159, and it'll go on forever and ever and ever, or you might know that as pi. So pi is just equal to the circumference of a circle divided by its diameter. Okay. Now, the diameter of a circle is just the radius times 2. Okay, so let me just scroll this up a little bit. Okay, so if you notice, the radius goes from the center to the circle. Okay, so if you got that radius and you went the other direction, you just have a radius plus a radius, and you have your diameter all the way across. Okay, same thing with your radius. Your radius is equal to the diameter divided by 2. Okay, so if you get your diameter and you cut it in half, you now go from the center to the circle, which is just your radius. Okay, so those two relationships are very important. You want to make sure you remember that. The diameter is just 2 times the radius, and the radius is the diameter divided by 2. Okay, now the circumference of a circle, we already know that the circumference divided by the diameter is equal to pi. But the circumference can be found, if you get this formula and divide both sides by the diameter, you get the circumference is equal to pi times the diameter. But we also know that you're not always given the diameter. Sometimes they give you the radius. And that the diameter is 2 times r. So if we replace the diameter with 2 times r, we get the circumference is equal to 2 pi r, or 2r pi, doesn't matter. Okay, so which formula you use all depends on what they give you. If they give you the diameter, you use this formula. If they give you the radius, you use this formula. Okay, now you have the area of a circle. Again, it all depends on what they give you. If they give you the radius, the area is equal to pi times the radius squared. Okay, but we know that the radius is equal to the diameter divided by 2. So if we get that radius and we divide it by the diameter divided by 2 squared, then we get the area is equal to pi over 4 times the diameter squared. So once again, which formula you use all depends on what information you have. If you know the radius, you'll use this formula. If you know the diameter, you use this formula. All right, so if you're still writing, feel free to pause it and finish up. We're going to go ahead and continue on the next page. And this is where we have the area of a ring. Okay. Now, you may see problems where they have a ring. They may call it a ring. They may call it a washer. They can call it various things. But this is the diameter of the ring. I mean, the area of the ring. So if you have two rings, one inside of the other, and you have just this shaded area. If you want to find the area of this shaded section, then you want to have the area of the outer circle minus the area of the inner circle. So if you get the area of the outer circle, you're getting the area of the entire thing. And then you're just subtracting the part that's open. Okay? So now, if you go from end to end of the outer circle, that's your diameter of the outer circle. That's denoted by the capital letter D. But if you have your inner circle, and you go for the diameter of the inner circle, that's the lowercase d, which is the diameter of the inner circle. Now for your radius of the outer circle, remember your radius goes from the center all the way to the end. So when you see the radius of the outer circle, that's denoted by the capital letter R. But when you see the radius of the inner circle, where it goes from the center just to the inner circle, that's denoted by the lowercase r. Okay, so to find the area of a washer or a ring or whatever wording you'd like to use, you get the area of the outer circle minus the area of the inner circle. Okay, now for those formulas, when you know the radii, which is just plural for more than one radius, you get the area of the outer circle, which is pi times the outer radius squared minus pi times the inner radius squared. Or if you factor a pi out of both of those, you get pi times the outer radius squared minus the inner radius squared. Now, if you know the diameters of the outer and inner circles, then you can use one of these three formulas. You can have the area of the outer circle, which is pi over 4 times the outer diameter squared, minus pi over 4 times the inner diameter squared. Or you can factor out the pi over 4 and just put pi over 4 times the outer diameter squared minus the inner diameter squared. Or if you plug pi over 4 into your calculator, it's approximately this value here. So you can use any one of those three formulas. Okay, so again, it all depends on what information you're given. If you know your radii, use either one of these two formulas. Let me put the or right here. If you know your diameters, you can use any one of those three formulas. All right. So if you're still writing, feel free to press pause and finish up. But we're going to go ahead and move on. Make that there in case anyone wants to pause it. All right, so we're going to go ahead and move on to our first example. The examples. All right, so here we go. We want to find the area of the following circles. We want to round the answer to 3 significant digits. Okay, so for the first circle, this is 10 inches. I'll let you figure out the rest. For the second circle, this is 17 inches. For the third half circle, it's 19 centimeters. Okay, now for B and C, you just want to use 3.14 for pi. All right, so go ahead and press pause and try these on your own. All right, so I'm assuming you've pressed pause and worked this out. So let's go ahead and verify. Okay, now for problem A, you notice that it's going from one end of the circle to the other. Remember, that's your diameter. So diameter is given. So we know that our D is going to equal 10. Okay, so when we know our diameter, we know that the area is going to equal pi over 4 times the diameter squared. Okay, so that means your area is going to equal pi over 4 times 10. Your diameter is equal to 10, so that'll be 10 squared. Okay, so that means your area is going to equal pi over 4 times 100 inches. Well, 100 square inches. That should be in inches right there. Okay, so if we plug that into our calculator, we end up with an area equaling approximately 78.5 once we round it to 3 significant digits. All right, so let's go ahead and verify question B. Now notice it goes from the center to a point on the circle. So we know that this is our radius. So our radius is given, so we know that R is equal to 17 inches. Well, I'll put inches there since I didn't put it there. There we go. Okay. Now, when we know the radius, we know that the area is going to equal pi times the radius squared. Okay. So we already know we're going to use 3.14 for pi for this one and for C. So we know that the area is going to equal, oh, forgot my equal sign. Area is going to equal 3.14 times the radius squared, which is 17 inches squared. Okay. So if we get 17 times 3.14, we will end up with our area equaling approximately 907 square inches. Okay. Now remember this part here, I kind of skipped a step, but this is just 3.14 times 17 inches times 17 inches. Okay, so you multiply those three, and you'll get this. All right, let's move up to problem C. I still want to have the shape available. Now notice this is a half circle, but if it were a full circle, we'd see it go, let's kind of just tap this in. I'm just putting that in kind of temporarily. But if you notice, if this were a full circle, you would know the diameter. The diameter would be 19. So let me go ahead and erase this because I don't want any confusion. There we go. Okay, so for C, we know the diameter is given. So we know that D is going to equal 19. Okay. Now, when you have a half circle with the diameter given, you just use the formula of a circle and you divide it by 2 because you're cutting it in half. So you can get the diameter of a circle and divide it by 2, or you can multiply it by 1/2. Either one of those will give you the same answer. Okay, so you have the area, let me move this up a little bit, is equal to pi over 4 times the diameter squared times 1/2. It's the same as dividing this all by 2. So whenever you have a half circle, you just multiply it by 1/2 or divide it all by 2, you'll get the same answer. Okay, now remember they want us to use 3.14 for pi. Remember, pi goes on forever, 3.14159, and it keeps on going and going. So we know that the area is going to equal 3.14. So if we combine these two, pi times 1 is pi, which is 3.14, and 4 times 2 is 8. So we get 3.14 divided by 8 times your diameter squared. So you have 19 centimeters. I keep forgetting to put that. Squared. Okay. So if we get our area equal 3.14 divided by 8 19 centimeters squared is 19 centimeters times 19 centimeters. Okay, so you plug all these values into your calculator, you get an area that's approximately equal to 141.692 centimeters squared. But if we round it to 3 significant digits, our area is approximately 142 centimeters squared. All right. So if you're still writing, of course, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Okay. Now for this example, you have an 8-foot strip of sheet metal that is bent into a circular tube. What is the diameter of the tube? Now for this one, it would help to draw kind of a picture or a diagram to help you visualize it. But I want you to pause it and try this one on your own. All right, so I'm assuming that you have pressed pause and worked this one out. So let's go ahead and verify. Okay, so just to help you visualize, let's say you have an 8-foot piece of sheet metal. Got a little tongue tie there. Okay, now you get that and you bend it into a circle. Okay, almost like if you had a piece of paper and you rolled it into a tube. So if you roll that into a circle, okay, so you get that. You know already that all the way around this is going to be 8 feet. Because all you did was get this 8-foot piece of sheet metal and roll it up. Okay, so you know all the way around that is just 8 feet. Okay, so what does that tell us? Well, that tells us that our circumference, which is the uppercase C, equals 8 feet. Okay, and they want us to find the diameter. Okay, so we know that the circumference is equal to pi times the diameter. Okay, but if we solve for the diameter, if we divide both sides by pi, we get the diameter equals c divided by pi, or c divided by pi equals the diameter. Okay, so our diameter equals the circumference divided by pi. Okay, so if you plug this into your calculator, 8 divided by pi, you get the diameter being approximately equal to 2.55 feet once you round it to the nearest hundredths. All right. Okay. So once again, you want to look at what information is given to you, especially for these story problems. Try drawing. I cannot stress enough how much drawing a picture can actually help you start to understand story problems. Okay. Usually that's the toughest part of math, but once you start drawing those pictures and really visualize what they're asking you, that's the part that helps. All right, so if you're still writing, feel free to pause it, but we're going to go ahead and move on to our next example. Okay, so we want to find the area of a washer with an outside radius of 7/16 of an inch and thickness of 1/8 of an inch. Notice it said the thickness of 1/8 of an inch. So once again, this is one of those problems that drawing a picture will really help, because notice, before you get started on it, said an outside radius of 7/16 of an inch. It didn't say the inside radius is 1/8 of an inch. It said it has a thickness of 1/8 of an inch. Okay, so I want you to go ahead and try this one and round to 3 significant digits. So go ahead and press pause and try this one on your own. All right, so I'm assuming you've gone ahead and press pause and finish this up. So let's go ahead and verify your answer. So let's go ahead and draw our circle. And let me draw the inner radius. There we go. Well, that should have been a little bit smaller, but that's good. Okay, so let's say this is our center. Okay, so we know our outside radius is 7/16 of an inch. So we know from here to here is our outside radius. So we know that our outside radius equals 7/16. Now it says it has a thickness of 1/8 of an inch. So that means the thickness means from here to here. That's the thickness of it. Now this is 1/8 of an inch. Okay, so what does that tell us? Well, we know that our outside radius means that R equals 7/16. Now, for our inside radius, remember your inside radius is from the center to the inner circle. We don't know that. We know the distance from the center to the outer circle, but from the distance from the center to the inner circle, we don't know. So what we do is we get the outer radius, because remember, the center to the outer circle minus the thickness. So if we go from here, the center to the outer circle, and then subtract the thickness, we'll have our radius, because we'll be right here. Because remember, we went from the center to the outer circle minus what our thickness is. So to find our radius, that's going to equal the outer radius minus the thickness. Okay, so if we multiply this by 2/2, we'll end up with, we have our like denominator, and we end up with an inside radius of 5/16. Okay, we have our outer radius and our inner radius. Okay, that's why I said drawing a picture is important, because instinct would have automatically told you, okay, you know what, this is my outer radius, and I'll just make that my inner radius. You don't want to do that. You always want to make sure that you draw a picture and you read it correctly. Okay, so now that we do have our outer radius and our inner radius, let's go ahead and find the area of the, well, the area of the washer, which is this shaded area right here. Okay, so we have the area of a ring, which is the same as area of a washer. It's going to equal the area of the outer ring minus the area of the inner ring. Bring this up a little bit. Okay, so remember that area is going to equal pi times the radius of the outer ring minus pi times the radius of the inner ring squared. Or we can just factor out the pi. So we have the area equals pi times the outer radius squared minus the inner radius squared. Okay, so now we go ahead and plug in our values. Okay, so we know that that's going to equal pi times 7/16 squared, since that's our outer radius. 7/16 squared minus 5/16 squared. Okay, so if we go ahead and simplify that, we have pi times 7 squared is 49, 16 squared is 256, minus 5 squared is 25, 16 squared is 256. So that's going to equal, since we have our like denominators, we go ahead and subtract. So that's pi times 24 over 256. So if we plug that into our calculator, 24 divided by 256, we get pi times 0.09375 square inches. Okay, which is approximately 0.2945 square inches, but rounded to 3 significant digits is 0.295 square inches rounded. All right. So if you are still writing, of course, feel free to pause it and finish up. We're going to go ahead and go to our last example. Oh, in case you were still pausing it. All right. So we want to find the area of a washer with an inside diameter of 1/2 inch and an outside diameter of 7/8 of an inch, round to 2 decimal places. Now this one's pretty straightforward because it tells you the inside diameter and outside diameter. It doesn't have you calculate for anything. So this one's pretty straightforward. So I want you to go ahead and press pause and solve this one on your own. All right, so assuming you've paused it, you've worked it out. So let's go ahead and verify your answer. Okay, so the area of a ring, when you know the diameter, is equal to pi over 4 times the outer diameter squared minus the inner diameter squared. Okay, so that's going to equal pi over 4 times your outer diameter squared, which is 7/8 of an inch, squared, minus your inner diameter, which is 1/2 inch squared. Okay, so that gives us pi over 4 times 7 squared is 49, 8 squared is 64, minus 1 squared is 1, 2 squared is 4. So if we multiply this one by 16 over 16, we'll have like denominators. So we have pi over 4 times 49 over 64 minus 16 over 64, which would give us pi over 4. And now we have our like denominator, so we can subtract. So that gives us 33 over 64. Okay. So if we plug our pi over 4 into our calculator, we get 0.7854 times 33 over 64. We plug that in, we get 0.5156. So if we multiply those two together, we get approximately 0.40495 square inches. And if we round that to 2 decimal places, it rounds to be 0.40 square inches. All right. So once again, you always want to wait and see what information is given before you decide on which formula to use. You want to know what they're asking for, whether they're asking for the area with the diameter or the area with the radius, and always read your questions carefully. Okay. Sometimes they want you to solve for the inner radius or solve for the outer radius and then plug it in. So you want to be really careful with that. All right. So hopefully this made sense to you, and I'll see you on the next video.